Agriculture sustains humanity, providing the food and resources we need to survive. But this vital industry is under constant threat from pests, which can devastate crops, leading to massive economic losses and food insecurity. Traditional solutions to this problem, such as chemical pesticides, are not without their own issues. But what if the key to protecting our crops lies beneath our feet? Welcome to Worm Terminator, harnessing native bacteria for sustainable pest control. Worm Terminator is an innovative project that aims to redefine the way we approach pest control in agriculture by using naturally occurring native bacteria to combat pests like parasitic worms and nematodes. Every year, farmers around the globe lose an estimated 20% to 40% of their crops to pests like nematodes and parasitic worms. These pests target the roots and leaves of plants, causing irreversible damage that diminishes yields and affects food supply chains. The solution we propose is simple yet revolutionary: native bacteria. These naturally occurring microorganisms have evolved in the soil for millions of years, interacting with plants and pests in complex, symbiotic ways. Some bacteria, like Bacillus thuringiensis and Pinobacillus polymyxa, have the ability to produce proteins and enzymes that specifically target parasitic worms, killing them while leaving the plants and beneficial organisms unharmed. By harnessing the power of these native bacteria, we can create an eco-friendly, efficient, and sustainable method of pest control that works in harmony with nature. Here's how Worm Terminator works on a technical level. The native bacteria we've isolated produce specialized proteins known as endotoxins. When these endotoxins are ingested by nematodes and parasitic worms, they disrupt the pest's digestive and metabolic systems, leading to their death. We begin by collecting root and soil samples from the rhizosphere, where beneficial bacteria and nematodes reside. Rhizobacteria and nematodes are carefully isolated from the collected samples, ready for further analysis. Next, we characterize the rhizobacteria and screen them for antimicrobial and nematocidal properties using C. elegans as a model. Through antinematode assays and microscopic analysis, we assess how effectively these bacteria inhibit nematodes. Finally, we measure the proteolytic activity of selected strains and perform statistical analysis to validate our findings. Our solution is applied directly to the soil through a biopesticide spray or integrated into irrigation systems. Once introduced, the bacteria thrive in the soil, naturally targeting the pests over time. What's more, these bacteria do not harm beneficial insects or microorganisms that are vital for maintaining soil health. The bacteria are cultivated using a bioreactor system that allows us to grow them at scale. Once harvested, they can be concentrated into liquid, powder, or granule form, making the application versatile across different farming practices. What sets Worm Terminator apart is the use of native bacteria, those already present in the environment. While many biological pest control solutions rely on genetically modified organisms or imported bacteria, our approach is rooted in local ecosystems. Because these bacteria are native, they integrate seamlessly into the soil microbiome, reducing the risk of ecological imbalance. This method also eliminates the potential for regulatory issues surrounding genetically modified organisms, making it more accessible to farmers worldwide. Worm Terminator can be applied through a variety of methods, depending on the crop and farming system. It can be used as a foliar spray or introduced through the soil. Farmers can apply it directly during planting or as part of routine pest management. The flexibility of application ensures that Worm Terminator can be adopted by small-scale organic farms and large-scale commercial operations alike. It is effective in a wide range of crops, from root vegetables like potatoes and carrots to grains, fruits, and leafy greens. The results speak for themselves. In controlled lab trials, crops treated with these native bacteria strains showed up to 100% damage from parasitic worms and nematodes. With this result, we can conclude this native bacteria strain can help make the crops healthier and lead to higher yields, which in turn means better profitability for farmers. Compared to conventional chemical pesticides, our solution is just as effective, if not more so, in the long term, without the environmental costs or risk of resistance. This research is proudly supported by a Fundamental Research Grant Scheme grant, also known as FRGS. The research and development behind Worm Terminator will be protected by intellectual property laws. We have filed copyright for the specific handling of nematode techniques on its cultivation and maintenance. This grant and copyright not only secure our innovation, but also pave the way for commercialization, ensuring that this sustainable technology can reach farmers across the globe. Our project, Worm Terminator using native bacteria, is currently at TRL4, where we are conducting controlled environment testing. We've successfully demonstrated the technology in the lab, and now we are refining the method to ensure its effectiveness and safety in simulated real-world conditions. With continued testing and validation, this innovative approach could revolutionize pest control in agriculture by harnessing the power of native bacteria. Our main competitors are chemical pesticide producers and biopesticide companies using foreign or engineered microorganisms. While chemical pesticides work fast, they harm the environment and lead to resistant pests. Worm Terminator stands out by using native bacteria to target parasitic worms directly, unlike general biopesticides. Though giants like Syngenta dominate, rising environmental concerns give Worm Terminator an edge as a sustainable, localized solution. Partnerships with research bodies like MADI and UPM can validate Worm Terminator and boost market entry. The global biopesticide market is expected to reach $6 billion by 2025, and Worm Terminator fits perfectly into the demand for natural, sustainable pest control. With growing regulatory pressures and consumer demand for organic farming, Worm Terminator offers a timely, effective solution. Strategic partnerships with cooperatives, research institutions, and government bodies will help scale Worm Terminator. Collaborating with MADI or NGOs will provide validation, regulatory support, and outreach. Worm Terminator will engage in pilot programs, farmer education, and marketing efforts, using social media and influencers to grow its presence in sustainable agriculture. The impact of Worm Terminator extends beyond the farm. By reducing the need for chemical pesticides, we are protecting the nation's water supplies, preserving biodiversity, and promoting healthier ecosystems. For farmers, this means lower costs and higher profitability. In the long run, Worm Terminator has the potential to support national food security, ensuring that we can meet the growing demand for food in a way that is sustainable for both people and the planet.